put them under lateral surface area. And we're looking at two different ones. One of them is a pyramid. So let's do a little, remember how to draw a pyramid? Sketch yourself out the best pyramid you can. One is a pyramid and the other,
A cylinder?
close. Actually, you have a cone.
I don't know if we already done that.
We haven't done lateral surface area, I believe.
Oh,
We might have done surface area and we might have done volume, but I don't believe
slant height.
we did
That,
slant
I was
height.
thinking of that.
We probably did that, but we didn't do. And these are nothing more than really knowing the formulas. And here they are. Of the pyramid, the book calls it this. A with the little s, what do you suppose that little s means? Surface area. Equals P S divided by 2. Which would lead you to ask the question, Jack.
What does PS mean?
Thank you. I don't know, what does PS mean? When you put it on an envelope, it means postscript, doesn't it? But not here. P is the perimeter of the base. P equals perimeter of base. And the S equals, guess what the S is? Yes, the slant height. Okay, so you're going to have to know the slant height, which remember is the area of the on one of the slanted sides. I think the book, does the book give us one? Whose slant height is 10 centimeters, that would be this. And whose regular hexagonal base, and each one of these is 5. Now, if you're really thinking mathematically here, normal lateral surface area of, what did that do? If this was a regular prism like this, how do we find the normal surface area? Or normal lateral surface area? Remember you did the perimeter of the base? Jeremy just asked that question, right? Perimeter of the base times the height. Well, this is very similar to that in that you do the perimeter of the base, but instead of doing the straight up height, which would be this, whatever it is, 12 or whatever, you do the slant height and then you divide it by 2. So doing it actually out, children, looks like this. What is the perimeter of the base? 5, 5, 5, and 5 gives you, what's the slant height? 10, right? They gave it to me there. And then you just take that and divide it by 2. So you're cutting it in half. So 200 cut in half is, the slant height would be 100. And area is always in what units there, Emma Kreis?
Something square.
Something square. I guess these were centimeters. So make sure you have this little thing in your notes. They will ask you questions. And then of a cone, here's the formula for the cone. Surface area of a cone is 2 times pi times radius. It's really the same thing. 2 times pi times radius times slant height divided by 2.
Radius squared or just radius?
Just radius. Which on top, what you could change that to what? Does anybody know on top really? I don't know why the book doesn't do it like this. Because John, it's the same as what? Oh, but there's, oh, yeah, you're right. I wasn't thinking that. Why do you suppose they do that? Why would they have you multiply by 2? Yeah. Well, I guess they do change it in the bottom. Yeah, so write this down, because these 2's would cross off. I think they're doing this because they're getting you to see that it's really the same formula as this. Because what's the perimeter? The perimeter of a circle is pi times diameter, which is what this would be. So write this down and make this one ARS. A times pi times radius times the slant height. 10, 12, and 13. Can I go to a different piece of paper here? Somebody say yes.
Yes.
Are you saying that because I told you to say yes, or because you really want me to? This is 10 centimeters from here to here. It is 12 high and 13 for a slant height. The one thing I would tell you to be careful with is make sure you're using the right height thing. If you're using that formula, area equals pi times radius times the slant height. Which one of those dimensions am I not going to use? Jackson Torah. 12, correct, because that's the real height. That's the straight up and down square height there. So this is actually pretty simple. You just area equals 3.14 times, what's the radius? 5 times, what's the slant height? 13. And everybody loves to do 65. Oh, look at the book. Let's just leave it in terms of pi, can we? Let's just make this a pi. Make everybody's life easier. Area equals 65 pi's.
How is this 65?
5 times 13. And then I just did multiply through by the pi because I am lazy at this point. I told you there's a point for calculators, kids. You're close to it. As a matter of fact, I would almost tell you at some point you could probably actually bring one. As long as you're not doing it for stuff that you shouldn't be able to do it for. Yes, Lucas?
So for the pyramid, it was 15 centimeters squared.
You lost me. So for the pyramid it was, no, it was 100. It's 20 times 10 was the 200 and I had to cut that in half. Where'd you get the 50? What's that? Oh, this one? No, the slant height was 10. It's this one here. It could be that my 5s were kind of in bad places here. My 5 was this line, this line. It was a square bottom to that thing. Now let me throw one last thing at you, because I know you're already way bored. Raise your hand if you're bored. Austin, everybody but you. They might ask you to give the total surface area of this thing. What did we find the surface area of, right, when we did this? What is 65 pi? 65 pi is it's the lateral surface area, which means it is it would be if you had the little cone here. Can I make a cone out of a piece of paper? Sure I can. If I had this cone, then we have a pair of scissors on right now.
Lucas does.
Lucas always apparently carries scissors. How do you know that? How do you know that?
That's the time in English. Or in Bible.
You just found the lateral surface area, which is you just found the lateral surface area, which is just the area. Wait, I need your scissors again. You just found the lateral surface area, which when you have a cone, is just like the paper that it was just this piece. Total surface area is missing what part? So if they ask you to find total surface area, what are you going to have to do? Yeah, just take this and add this bottom circle to it. And what's the area for the bottom of the circle? Pi times radius. And that should be pretty quick for you because what is it? And then you can just add your 25 pi there and get 90 pi. Why can I put 25 pi with 65 pi? Because they are like terms. I couldn't do it if it was just the 25. 25 and 65 pi are not the same. Pi is the same as an x. You have to add it there. Congratulations, kids. We survived one more together. Jackson?
Yeah.
Oh, I thought you had your hands up, no? Let me see what I have for you, kids. You can tell why you're mentally drained after that.
I can see why.
Because I am.
I'm much better than the language arts stuff.
Nick, you know all this, Nick, all this, you're treating them for those. Nick.
Yeah.
Alright, let's try to figure out what we should do on this. Cal is being awful hard on you.
Oh, I don't think so, Mr. Hunt.
Wait, I did want to.
Miss Lopez says we got
Ms. Lopez could be close.
It is Wednesday.
We don't have a lot of time. We usually don't. That's why I said block scheduling would be good.
That's true. But today would be the last day of assignments, Mr. Hunt, because tomorrow they're gone.
Well, that's true, you do have 5 days off.
So we could just do one tomorrow.
Anyways, look up here, children, because I did want to talk about this, even though nobody asked about this. On the assignment here, you asked about this?
Yeah, we did.
Well, I didn't have time to throw it out at you. Okay, this is already solved as far as it's gonna get. Okay, you're not moving this 7 over here or doing anything. For the simple reason is, you've got 2 inequality signs right there. If it would have said 7 plus, if it would have said 7 plus x is less than 10, then yes, by all means, you would solve that for x by subtracting that over. But this is already solved as far as you can go. And you have to look at this as being this. This says x is greater than or equal to 7, and that's why at the number 7, you color in the circle because it can be equal to. It's any number that's greater than 7, so it goes that way. This says and x is less than 10. So at 10, it's an open circle because there's no equal there, but it's everything that's less than 10. So the answer to the problem is anything that falls between 7 and 10. So that's why you color it in. Not to be mistaken for problem number on today's assignment, which is number 10. That is an OR problem, and again, that one can't be solved any farther than it is. If it says OR, that means either one of them can be true. So this is one usually where it ends up being that they go in opposite directions. It's the difference between an AND problem, which this is, and an OR problem, which this would be. So here you would just have an open circle at -12 going backwards left, and closed circle at -6 going forwards right. They don't overlap, they actually go in opposite directions. Now, back to what we were going to do there, because I don't know if you caught it. Well, no, we have to do number 1. How about this? Let's do anything that is what or above?
100, 90, 100.
Oh, 100.
There's a 95.
95? How many is 95 or above? I don't see many 95s.
How about 90?
What about 92 and above?
There's
3 problems for 95.
Just do 90 and above.
No,
Yeah,
there's
90
a lot
and
of
above, that's
90s.
like
93.
How many 90s are there?
9.
How about 80 and above?
No. How about 90? I'll go 92 and above.
Okay.
Look at that.
Which means 16, 17, number one. It's not many more, it's probably only 3 more than you were gonna do anyways. 18, 16, 17, 18.
Number 8, 5, 6, 7.
Sweet.
Well, it's gonna take you a little while to do number one.
There's only 7.
Green calculator.
Yeah, there's only 7.
No.
So you're gonna calculate.
Notice problem number one tells you to do it in terms of pi, so you don't have to multiply by pi. Thank you, John. 7 problems.
1, 8.
Holy stick, we should have to take papers.
We have